9.4 logarithmic functions. So this is a special type of function in order to be able to solve certain equations. And so we want to be able to look and break down what that is here today. Okay. So let's get into our definitions. And so our first one here is actually going to go back to 9.3. We didn't cover 9.3, and that's okay. We just need a couple of details from that, but we just didn't like the questions and the things there. So we can get our definitions from there and then move on into what we have here in 9.4. So our first one actually comes from 9.3, and it's called the exponential function. Okay, and this is a function where it's f of x equals a to the x power. So notice that my variable is in the power here. But we do have to know where x is a real number. Okay, so x does have to be a real number. A has to be greater than 0, and a cannot be 1. Okay, so a does have to be positive for that, because if it's negative, we get some weird stuff going on there on those. And then it can't be 1 because 1 to any power is still 1. So we do need those two pieces. Okay. Also from 9.3, we have what's called the natural number. Okay, and the natural number, we denote E as our letters, kind of like pi or I that we've looked at before. And this is approximately 2.71828, and it goes on forever. Okay, and it never repeats, kind of like pi, but it's one that just keeps coming back up over and over again. And so it got its own letter. All right, our next definition is this logarithmic function. And so logarithmic function. So this is a function in terms of y equals log. What we have here is base a of x. Okay, for those. So it looks kind of funny there. We have a subscript a for that. And we do need this to say such that we could rewrite this x equals a to the y value, okay, for those. And so what we're looking here is being able to rewrite things so that we take them out of the powers. It creates this logarithmic function to be able to do that. So it's an inverse of those pieces. And works through them. Okay. Now we do need here where x is greater than or 0, and much like before, a must be greater than or 0, and actually it should be a constant as well. So let me fix that. A is a positive constant other than 1. Okay. So again, it's got to have those things. A is still going to be positive, but we do want it to be a constant in this case for those. Okay. All right, and this is red. So I'm going to put down here red. Log base a of x. Okay, so that's how you hear me say that. What I'm going to talk about that base and those types of things when we work with that. All right, for those. All right, the next thing I need to erase to write is. Let's get a little space here. For properties. of logarithms. All right, our first one, log base A. This means, or log A, sorry, I'm struggling today. So log A means log base 10 of A. So notice here, I did not write a base. So this is one that we call our common logarithm. So if we do not write a base, it is known to be base 10, okay, for those. So you just got to memorize that. So when you see log with no base written, you know it's log base 10, okay? We do have another one. It means ln of A. So you'll notice I write that in cursive so my L doesn't look like a 1. So ln A, this means log base E of A. So this is our natural log, is why we call it that. So our natural log of A there. So we won't ever write log base E, we'll write ln for those. Log base A of 1, this will always equal 0, okay? Now the reason for that, why is that? If we were to use our formula and rewrite this thing over here, this is because A to the 0 equals 1, okay? So A to the 0 power equals 1 for that, and that's what we can do here on this. You'll notice we look back here, A to the y power equals x, okay? So that's the same thing that we have. So we can rewrite those pieces. That is something we are going to have to do later on. We'll look at that. All right, our next one, log base A of A, this equals 1, okay? Again, why is that? So here to the side, if we take our A on the base, so base A to the power of 1 equals A here, okay? So we're always going to have that piece, okay? Now we as well have a couple others that are very similar to those last two here. So let me erase again. Actually, I think I can get this down here in the bottom. Here's enough room. So E is going to be ln of 1. That still equals 0 as well for the same reason here, because it's base E. So E to the 0 is still 1. So it's the same thing. And then definition number F, ln of E, this equals 1. Okay. Now, again, it's the same thing, because that means log base E of E. So we still get to that 1, no matter what it is for those. Okay. So these are things that we want to utilize. Our last one here is the change of base formula. Okay. And it states log base B of M equals log M over log B, or it equals ln of M over ln of B. Okay. Now, the reason why we have this, it's a ratio for these. We have this formula is because your calculators will do some work for you. Again, begin to look on the calculators that you can use for your class. You will notice that there is a log button and there is an ln button. Okay, it may be in smaller notation of things or in the background where you have to hit second and then something else for those, but they are there. And so the log button is only base 10, and then the ln button is your base E. So we can move things around. Our change of base says that if I have a different base, then I can rewrite it where it's log base 10 of M divided by log base 10 of B for those, because of the way the ratio works out for them, okay? And so you can use that for those. Now, if you do that on your exams, you're going to have to tell me that you're using that formula, that you did the change of base, and that's what you got, okay? So those are things that you can do there. All right, so let's look at our examples here and see what we're going to do with these. All right, so our first ones are find the logarithm. Okay, find the logarithm. And so number one, we're going to find log base 2 of 16. Now, there are different ways to work these. Some of these we can do by hand with thinking through the math process, doing a little bit of rewriting. So that's how I'm going to approach these. I want to be able to take them and do all those pieces with them, okay? So what I'm going to do here is I'm going to imagine just for a second that we're solving for this. And so since we don't know what the answer is, we're going to call our answer x. Now I'm going to use what I know about logarithms. I know that I can rewrite this as our base 2 to the power over here, and that equals our 16, okay? So now instead of reading log base 2 of 16 equals x, it reads 2 to the x equals 16. Now, why do I want to do that? Can I take 16 and write it as 2 to some power? And I can, okay? 2 to the x over here equals 2. 2 to the 4th power gives me 16, okay? Well, since our bases are the same, that means our powers must be the same, so x must equal 4. And that is our answer, okay? So that is one way to do the problem. Now, another option here, so formula, if we want to use the formula, we can just simply say log 16 divided by log 2 equals. Now we're going to have to put that in our calculator. You're going to have to put parentheses around those numbers for those. If you do that, you put it in your calculator, you write down this formula and show it, you should get 4 as well for those. Okay, then we'll get you to the same place. You just got to make sure that you tell me what you're doing in the calculator. I'm doing the formula. So you got to write down your formula if you do that for me, okay? So make sure that you're doing those details. All right, now, of course, I'm not going to use the formula. I'm going to do it by hand. I'm going to show it how to kind of think through these problems on the rest of these, unless I just have to use my formula. So that's the way I'm going to approach it from here on out. So number 2, we have log base 2 of 1/4. So again, I'm going to put it where it's equal to x and then solve for x. So equals x. I'm going to rewrite. So our base to what it equals is equal to what we're taking the log of. So 1/4. 2 to the x equals 1/4. Now, we may not remember exactly how to write 1/4 as 2 to a power, but I do know how to write 4. So this is 2 to the x equals 1/2 squared. Well, it's on the bottom. It doesn't just say 2 equals 2 here, but I can change this. If I move it to the top, that becomes 2 to the x equals 2 to the -2 power. So now my bases are the same, so our powers must be the same. So x must equal 2. Okay, so those are ways that we can break that down. Number 3, log base 3, the 4th root of 3. Okay, let me erase this real quick. All right, so again, I'm going to use that same process. I'm going to try to see if I can maneuver these things around. And so I'm going to put equals x. So we take our base of 3 to our power here equals the 4th root of 3. Okay, Now, if we remember on this, we can always rewrite this as 3 to the x equals 3. Our power goes on top, our root goes on bottom, so to the 1/4. So that means x equals 1/4. Okay. So if you can remember those little things, we don't even have to touch our calculator. We can knock that out really quickly. But I do want to see these steps. Okay, I want to make sure that you are rewriting that so that you know why. I just don't want to see you write the answer down because I'm going to think that you're cheating if you're doing that. I want to see that you know why x equals 1/4. It's because we can rewrite this thing. It's log base 4 of 100. Okay. Log base 4 of 100. Again, I'm going to put x here. So that means 4 to the x equals 100. Well, we break that down, there is nothing. Okay. If we do 4 squared, we get 16. 4 to the third, we get 64. 4 to the fourth is a really big number. Okay, so I don't know, I think it's like 216 or something. It's not anything, it's 100. So this is not going to work for us here because it doesn't come out evenly. So this is a case where I need to do log 100 over log 4 in my calculator for those. Okay, so we go to our calculator, we put those in, then we are going to get approximately 3.3219. Now make sure you read your instructions on how many decimal places you need to go to be able to get the correct answer there. Pearson will always tell you how many to do that. I'm going to go usually about 4, but they may go less. Okay. 5 log 10 to the -6. Okay. So again, I'm just going to rewrite this. So let's put our x there at the bottom or at the end of it. And remember as well, this is a base of 10. Okay. And so here we can do 10 to the x equals 10 to the -6. For those. So just that quickly, we can see x equals -6. ln of e to the third. All right, so again, I'm going to put equals x, remembering that this is a log base e. So if you need to rewrite this, this is log base e of e to the third equals x. So this e here to the x power equals e to the third. So that means x equals 3. We're going to find we always have that property there on those. Okay. 7 log base 2 of 1. Now this one we can actually just go and look at our definitions on our properties, and we see anything that we're taking, doesn't matter what the base is, of 1, always equal 0. Okay, we don't remember exactly which property that is, but it's always going to happen. Okay. All right, last couple things. Convert to a logarithm. E to the third equals t. So we do need to be able to go back and forth from exponential to logarithm, logarithm to exponential. And so we want to be able to do that. So we're going to have to do that throughout the rest of this unit. All right, so here is our base. Always remember that this is the base. It's called the base when we're talking about exponents. It's also going to be called the base when we're talking about logarithms. So this is going to tell me that this is log base e. Well, now we need to figure out, we have a number going in these two spots. Well, if the 3 is already touching the e, means it goes on the other side over here, and the t is now touching that. And make sure that you write that base as a subscript. But technically here, if it's log base e, we said that is ln of t equals 3. We never write log base e, we write ln on those, okay? If we can convert to a logarithm, we want to be able to convert to an exponential. Okay. So here we have log base 4 of 7 equals x. So just like we did earlier, here's our base. So we're going to have 4 to the x equals 7. And we're not solving, we're just converting is all we're doing there on those, okay? So we work through that. Now, pay attention to your powers, where things go on them. You'll always remember your base. When you go to rewrite it, you'll have your base. It always goes with what's opposite. So now it's 4 to the x equals 7. They have to change positions with no matter which direction that we're going, okay? So that's our introduction into logarithms. We're going to start expanding on those. So make sure you can convert and find your basic logs at the end of this.